Okay, I'm very sorry about this stream yesterday that basically died. Well, it didn't die. For some reason, it didn't stay recorded. So what I'm doing is I'm copying this stream locally. So if YouTube decide they don't want to post it later, then I can upload it later. So just putting on my other pair of gloves. So I'm going to quickly run over a number of the things that talked about yesterday, which are now lost. It's a shame. There's some interesting tidbits in there about the active agent and so forth. Maybe we can capture some of those now. Anyway, so I've come armed with a number of tools that I want to briefly go over that I discussed yesterday at much greater length. If there are any specific questions or someone wanted to be reminded of something that was said yesterday, then let me know and I'll see if I can work out what I said yesterday. So anyway, now first up I wanted to do some magnetic tests, and here we have some magnetic paper. And I have a piece of brass here, which is like a little hook like that, and if I put this on here, there's no sort of response from it. You can see the color through, but you can't see any magnetic response. I have some nail clippers here, which actually turn out to be surprisingly magnetic. So if I come here, maybe it's going to do it for me. I don't know. It's not the best example. I need a big magnet. Anyway, trust me, this is magnetic, and we'll see it on the phone. Like there you can see, maybe you can see it. Oh, there's a terrible demonstration, Bob. I'm gonna do it. It's not a very good demonstration, this, but if I had a magnet, it would be better. You'll see it working on the phone. So basically, you'll have to take my word for it, but I did do this earlier, and there's nothing coming out of the front of there in any sense of magnetic sense, it would appear. And so I'm going to move the camera down and have a quick look at this phone. I've got my phone here, and I have a multi-tool, and I'm looking at the magnetic sensor here. So you can see as I move that around, it changes the XYZ magnetic sense there. So I'm going to just look at the thermocouple, and I'll bring the camera down. Maybe I can get a nice static view of the sensor. Maybe just a nice close-up of that. Can I do that? Is it going to be possible? We can try, we can only try. This is not the best. Not the best. Okay, what have we got there? That's not good at all, is it? Oh, right. Can we see down there? Can we get it to look down on the sensor? Okay, all right. Now, the actual sensor on the Galaxy S7 is still not high enough. The sensor on the S7 is here, and what I can't quite see the graph there. I'm going to have to lift it up just a little bit higher. Let's try putting this in there in place. Okay, so this might be enough. Yeah, in total. Right, can we see you can see my cracked phone there? I said cracked. Oh dear. Maybe with that in place, we can get something half sensible. Okay, so what's that going to give us? Okay, so there we go. We can see all of the important bits, I think. Okay, so the sensor is here, and can we get that in view? as well. Okay, so you can see the track lines there. Now, if I bring our piece of brass in here and bring it over our sensor here, in theory, we will have nothing of any interest because it's brass. Okay, so just check that's the piece, that's the brass look I was showing you earlier, and we have no detection of anything there. Now I'm going to show you the nail clippers, so you can see what happens when I use the nail clippers, and then you might believe me that it's magnetic. So there we go, a real strong signal from our nail clippers here. If I move it up and down, you can see it responding quite nicely. If I turn it around the other way, it's going down now. It's going in the opposite direction. And here it goes up. So it's actually even more sensitive if you go over here. So look at that. These nail clippers are pretty intensive. Okay. Actually, you can see the micro Teslas up here. I'll turn that around again. And you can see it there. So the graph's a little bit more interesting. Okay, so let it settle down again. So that's its static position, and that's saying, those are the figures there, not overly interesting. And again with the piece of brass, piece of brass, no change whatsoever. Okay, so I'm going to introduce the nuked thermocouple. So here it is. I'll bring it up there. You can see it there. It's really in a bad way. That's the thermal well outside, which looks like a piece of carbon now. In fact, it looks very much like the steel rod that we processed in Suhas Rao-Carr's foil processor. But if we bring it down here, and it's not the most inspiring thing, not a lot of change, not a lot of change, and we've got a bit of joy as we get up this end. Now, is it this metal up here? This metal seems to be doing something a little more right at the end here. Get more of a change and come back down. So is there a step there? There's the step. Right at that end, right at that end. Right at the very end. And we move, and it drops down. And we move up, and we go down. So just right at this end, and then if you come down here, a little bit of change, not a lot, not a lot, not a lot. And then in here, these broken bits, there's a broken bit there, sudden change, but very, very slight, very, very slight. So I'm literally, there's a crack in the thermocouple sheath, and as we move across that crack, there's a little change. So, and then come down to the other end of that crack, that section rather. So that's the end of that section, and come down to this part of the section, and then look at the last bit here. There doesn't seem to be a lot in that last bit there. In fact, it's not doing anything, that last bit. But if I move it away, it's not doing anything. So that last piece seems to have very little magnetic effect. Okay, the next piece seems to have a little bit. Okay, and then as we step over that join, well, that was to step over the join. So the step over the joint is a big jump there, but there is some action with that middle section. The end section, pretty dull, nothing of real interest going on there. Let's try getting it on the edge. Yeah, literally nothing of interest there. The middle section, that is just this little bit of change. Then there's a big step change on that crossover between the middle section and this last bit, and then it kind of, it's pretty steady. Got a bit of a change as we go onto the bolt area here, and then yeah, over that bolt area. So obviously there's some different metals here with different properties, and it'd be interesting to do a similar test on a unused one of these thermal wells. And so I'm going to run all the way down here, so there doesn't appear to be much of a change, and then as we get to the end here, there's a big shift on that end. I mean, when I say big, it's nothing compared to our scissors, but there is a shift on that end. Notion, nothing, big shift, nothing, big shift. So what I'm going to do is I'm going to push that up to get some metrics. You can actually see the metrics there. So down on the end, our super charcoal converted to charcoal end. Look at that. That does not look like a stainless steel thermal well anymore. Okay, so .9. Let's see which one is changing the most at this end first. Okay, so the very end of this is it's giving us figures of around minus 40 Tesla, micro Tesla, minus 40 Tesla, yikes! Every piece of metal in the building would be flying over here. Magnetic metal. Okay, minus 43, okay. So that's 35 shift there. Now if you come down this end, it's saying minus 20. I'm just looking at the X there. Other people can track other things. So saying minus 20, minus 23. Not a lot of changes there. And basically the same, wherever you have it. In the next section, go along that, 23, 22, 19. Now it's shifting the other way. Okay. So on that transition there, it's going all the way down this middle section. It's 23, 23, 22, 21. And then on the transition between the two, the middle section and the piece that's attached to the rest of the thermal well, it's dropped to the minus 11. And we're going to follow all the way along there. Now it's rising. Now it's rising. Now it's rising. We're back to 20, which is, remember what we had down here on this bit, 22, 20. What does it all mean? And now we're going to go on the edge here. Right, this is going down to, so there it's minus 17, 18, and down here it's minus 5, and then we go 4, minus 4, minus 4, minus 3, minus 4, minus 8, 9, 10, 9. And then we come to the end, and we've got minus 40 again. What does that mean? Don't know. Maybe someone can map that out. Okay, so I'm just going to move this out of the way. Actually, we'll have a look with the gravity sensor just to see if there's anything there at all whatsoever. So again, there's our gravity doing nothing interesting. If we move this around, you'll see that it responds to being shifted around, as any MEMS device you would expect to. Okay, and then I'm going to try and, actually I don't know where the gravity sensor is on this. There. Okay, so it's probably more embedded. I'm not getting any joy. I did have a look at earlier, but I didn't really get any joy. So anyway, there we go. That's the magnetic nature of the thermocouple, and it does appear to have some variation at this end piece here, which is cracked off and looks a bit like a piece of charcoal. That doesn't appear to have any magnetic nature to it at all. This bit here, I've got this all in blurry vision for you. How's that not focusing? And this middle section up to this crack, a little bit of change, big change, well, big change from the little numbers. Over the gap there, then sort of fairly consistent, something going on with the bolts, and then just nothing, and then a slight rise up to this end where we have the biggest shift. So that's what it is, that is what it is. Okay, so I'm going to move things around and just discuss a couple of other things, the metrics that we wanted to gather. Okay. Right. Now, I've got a picture here of the webcam, and I discussed yesterday my thinking that I wanted to strap the webcam, and let's just get that. It's actually a Logitech 920C, and where is it? We have a gallery picture here. This is the webcam that you're actually seeing this through. It's that one of them, okay? And what I looked at was, I was thinking of putting some card there, but I was trying to find card that didn't have any plastic cover on it. You know, like you get that plasticized card. And I didn't want any of that because we know that that would add another layer and strange radiation wouldn't want to go through it. So I'm effectively putting the card in front of there, and 3 of these pieces of card was sufficient to block out all the light. Then I got a bit of a brainwave because obviously this thermal well here has been seriously affected. And what I'm thinking of doing is I'm thinking of taking the end of the thermal well here and essentially just strapping it to the front of the webcam. So where we've got the, where's the webcam image here? Literally getting that thermocouple and strapping it on to the perspex here. Wow, there's some Nivea cream there. Strapping it onto the front of the perspex here, and then basically shielding out the rest of the light by having a piece of plastic on the back of this paper, which is backing onto this foil, so that there's only hydrocarbon touching the sample, so we don't contaminate it. And then basically sticking this foil around it. So we'll get protection from environmental strange radiation, and we'll also get reflection potentially of the strange radiation that may or may not coming from that sample. So we get a kind of win-win scenario, cut out the background potentially, and enhance the local thing. But what I'm really trying to do effectively there is completely minimize the number of materials that are between the sample and the sensor on the CCD. So essentially, I'm going to, just to clarify that, it's going to be stuck. I'm going to take the end of that thing, which is basically like a piece of carbon now, stick it onto the front of the webcam, and then a piece of plastic on the back of it, and then some of this, and wrap it around the webcam front and back, and bind it all in so there's no light coming in. So that's the plan there. Now, what I've got today, I got a battery. I said yesterday I needed to get a battery for the remote here, and this enables me to take shuttered photographs, like different exposures, and I have a 50mm lens here. This gives you nice high clarity, sort of low distortion imagery. Then there's this zoom lens here, and I'll just demonstrate basically, turn it on, and this allows you to, when it's warmed up, I can go like that, and it'll take a photo. This means I'm not jogging the camera when it's taking, bracketing like 3 shots to make a high dynamic range image. And then, turn that off again. This is lens that really helped understand the process going on in Lena. This is probably the most important thing that your donations brought in the last several years. Essentially, when I was seeing those tracks being formed on the Echo fuel container that seemed to be tearing the container apart, like the container that it's so funny. It says, I must warn you that this fuel tends to, shatter or break up plastic containers or whatever. And he lifted it up, and as he lifted it to about this height over the desk, just under its own weight of the contents in the bottle, it just fell apart, and just the bits of plastic went everywhere. And it was like, good demonstration, Suhas. Anyway, the next major presentation, when I'm talking about the strange radiation and active agent sort of life cycle, really this was so important, along with what it showed with John Hutchison's work and other samples, and the lion. So that those 3 really were absolute key into unlocking this mystery, in my point of view. Now, I'm just going to go and close the door out there, because there's a lot of background noise here at the moment. So okay, so back in the room. Okay, that was these 2 lenses. Now, I'm going to take this off the table because I want to demonstrate the Prime Sense, which I have got kind of working today. They've updated the software, and for some reason it's not seeing my graphics card, my GPU. So I can't get the highest quality I'd like out of its scanning. I've done a couple of tests, but I'm actually going to do a test for you live. So I'm going to first show you what the structured light sensor looks like. It's funny because you can't normally see this. When you look at it, it's just like a little bit zizzing. But if I actually show it into the web camera, you can actually see what the structured light is. So look at that. So when you are next having your social score measured by some people that want to do that and find out who you are, then this is the now off the table technology that will allow that to be done. So there you go. So that's structured light from a PrimeSense Carmine 1.09. This is the best one that was available before Apple took it off the consumer table. In fact, this was never really available to consumers. You could get it for animators. Anyway, the software I'm using is called ScanEct. And what I've done is I've set it up, and I'm just going to switch over here to this software. Okay, so it's up in the corner here, and I'm going to move the. Can I move? Is this? What's going on here? Right, I'm going to move the. No, I want to go this way. I know what you can do. I can do this. Look at that. Look at that. There we go. So here's our looking for heat robot, and these are 2 reactors, and they are. I think he said it was like a line 2. I said the other day, but he had 2 going, and one he obviously favoured because he has these 2 ports in here. So I'm just going to do a quick demonstration. Obviously, I'll spend more time on doing a proper scan for you, and then publishing that, so that we have a 3D model that you can play with and I will do that now. This is like getting an external volumetric data. Lion is keen to use an NMR, nuclear magnetic resonance, or something like a CT scan to get an internal volumetric data set. So, but first I'm going to see what we can do with this. So I'm going to basically, what I'm doing is I'm saying this is an object, and I'm saying it's roughly 30 centimeters by 30 centimeters by 30 centimeters, and I am going to attempt to scan this now. Let's see what happens. Why is that doing that? Maybe it doesn't like two cameras. This is when my oh no, it did work. Let's try again. Start. Okay, there we go. Can you see that? Lovely. Okay. So it's giving you. I don't even know how to. In the top right, you've got the depth information and the IR information and the color information. So in theory, if I can get this, I just need to check it's actually in the box. So yeah, you can see I want to get this in the box, as it were. So this might be an epic fail because I'm trying to do things as well as speak to you guys, but so. Okay, sorry about the orientation issues. That's not so bad. Okay, try. Is that in the box? Is that in the box? I'm trying to think inside the box here, so to speak. Okay, so okay, is it good? Oh, it's giving me no feedback. Oh. You know, it's because I got the USB doing the camera at the same time. I'm gonna try and start this again, new, and I'm just going to turn back the feedback onto a little bit slower because it might just be saturating the USB with the webcam as well. Okay, close that. So doing. Now you have to keep it like a working distance away from it. It's actually useful if you have just random blobs and stuff on the table that it can then use to reference. Okay, if I move too quickly, I'm going to lose this, which is always annoying. It takes a little bit of getting used to. Oh, I've got the camera tripod on the floor. Okay, I'm going to try and come round without losing anything. No, I'm caught around the table. It's always good to clear your workspace when you're doing these things. Okay, let's see if I can come around and grab the front side of this. Okay, I'm gonna call that a day. I'm not gonna capture the other side, obviously. So it's gonna try and sync those frames up. Okay. Okay, now I'm going to go to the, it's still synchronizing the frames. It's probably because it's doing stuff in the background and streaming. Oh dear. I can see the stream's gone a bit wonky. Okay. Right, okay, so if I cut to here, you should if we go to reconstruct here, we should be able to see our looking for heat robot. Okay, so it's not perfect. Like I say, you can see there's a shadow here where it hasn't got the data, so it's trying to have to guess. But when I spend a little bit more time, it will get a much better job of that. And of course, you've got some undercuts there as well. Now, what I can actually do here is it's going to fuse a load of lumps together here. Now, with the GPU, it makes a much better job of this. Really, just does a much better job. And I've only selected medium fidelity here, so it's not going to be perfect. If anyone's got any questions, they can just fire away. So it's processing it. What I'm going to do is I'm just going to cut whilst that's doing that in the background, and I'm just going to talk about some other things. First, I think probably what I want to do is I want to try and capture the resistance of this half of the coil and this half of the coil. So you can see it processing in the background there. So I'm going to try and do that. So let's try and get the webcam in such a position where it can see the meter. Maybe you can see it if I do it like that. Let's put the meter over here. So I've got the meter here. I'm going to put this onto ohms. Okay. Oh, now you can't see what I'm actually testing. That's not so good, is it? Okay. Well, I think what we'll do is you want to see what I'm testing, don't you? Maybe we can do it like this. How can I do that? Change the screen a bit. Maybe I can get it to do like that. Is it going to have enough resolution? I don't know. Can we get this in a way that you can see it? Maybe like that. Okay. Where can we put this so you can see it? Let me put it there. Okay. Right. Is that visible? That looks visible. How about that? There we go. That's visible. Actually check on the screen. Yeah, you can see that on the screen. Okay. So, what are our resistances? Now, this is actually quite a nice little device that was bought in India when we did, and I think a third trip to see Suhas with Dr. Eagley last year. And it's quite good because it auto ranges, and there's a whole button there, but I haven't got a third hand, so I'm not going to be able to press that. Put the structure sensor, not structure sensor, the prime sensor underneath there. Okay. So I'm going to take the sharp point of the common, and I'm going to push that into the middle of the joining junction here, and I'm going to do first the resistance of the reactor heater. Sorry, the tube furnace Cantal wire that's attached around or rotating around the quartz of the small bolted Lion reactor, which has the 2 extra holes. This is the one that he was more interested in, it would seem. So I'm going to touch on the back, and I'll show you what I'm touching on the back in the middle of later. But what are we getting there? We are getting 1.8, 1.9 ohms, 1.7. Try to see if we can get a slightly better contact on that. Okay, so this one's coil is a 1.8 ohms. Okay. I wish I could get my. Can I get my nose in there to press the whole button? Oh yes. Okay. Right, where there's a will, there's a dispute. Oh no, what's happened now? Oh, it's gone over limit. Where's my... It's not a very good hold button, is it? Let's try that again. I want you to believe me that it actually says ohms and not something else. Right. Oh, this is ridiculous. I'm going to have to use my nose again. 1.8 ohms, okay. Stay when I take that off. Quick. 1.8 ohms. Oh no. There's probably someone out there saying, you have to do this. If there is, can they put it on the chat? This is when you really need an assistant. Okay, you know what? I'm going to bring the camera down so that you can actually just believe that this is 1.8 ohms for this one. So I'm going to get that right close in there so you can actually see what it says. I'm going to do it right. Okay. Ta-da! I'm going to switch to the other one. Okay. Oh, you can actually see me in the background doing that particular. I'll do that. There we go. Right. So you can see me on the right one. Okay. Right. So I'm going to connect to the joining block. And onto the back. .9 ohms. Okay. 1.8. Oh, there we go. 2 ohms. 1.9. 1.8. Somewhere around there. Just to show you what I've been connecting to. I've been connecting to this center part here, and I've been connecting to. You see that little scratchy mark? Oh, where is it there? Okay. Focus! There you go, that little scratchy mark in the center. That's where I've been connecting to on the back of that. Okay. I'm going to do the same for the other side. Why not, indeed? Okay, so again, I'm going to put it onto the center point over here and onto the center of that block on the other side. What have we got there? I'm actually now reading off the catcher. Okay, that's a bit different. 17.7 megohms, 18.2, 18.37 megohms. Okay. Something clearly has happened to the coil on the other side. Yeah. I've got a good connection here. Right. So the coil on this side, I'm just going to do the other angle so that you can believe me when I'm telling you. Okay. Again, I am done there. Can you see that? Yeah. Okay. So I'm going to go on here. And over here. In the center of the back here. What's it got? .26 megohms. Okay, they are not the same. Obviously, they are not behaving in the same way. Okay, right. I'm sure you'll have something to say about that. Now, the next test I said I would wanted to do tomorrow, yesterday, I'll get my future and past mixed up. Put these back together. I don't know if I've got it. What I wanted to do is connect the device to the radiator, but I want to get the temperature of the room first and see if any of these holes in here have a different temperature. Okay, so I have one more bit of plastic which seems to have gone walkabout. Okay, I'll put that there. I'll find that a little later. Okay, so a little K-type thermocouple here, which we can throw in here. And we turn that on to degrees centigrade. What have we got in there? Yikes. Can you see what it is yet? We've got a 24 degrees centigrade there. And just to show that it's working, I'm going to go and put my fingers on there. There we go. Oh yes, I will do that. Yeah, so very good. I will make a measurement on the shorted meter. I'll do that right up close as well, just to confirm that it goes to 0 in theory. Because you're right, because the resistance of this one was quite low, and therefore that might even be the resistance of the leads. So let's check that. Okay, so that's showing 32, so I'm probably dead. Anyway, let's let this cool down. Whilst that's settling down, I'm going to go and do that test. Thank you very much. No, we don't have the Geiger. The Geiger's actually with Lion. He's actually in possession of our Geiger. So that's where that is. He didn't report any horrible Geiger signals, and that's not so surprising. Right, it's tight in there. Okay. I think if I had a Geiger, it would just scare me and I wouldn't do any tests. Wow, that sounds responsible. Okay, so we're going to do a says over limit there at the moment, and we're going to join these two together, and we can get a decent connection here. What's it saying? Oh, that's the temperature. I get the idiot prize today. And it's gone to its most sensitive range, and it's reporting 0. And put a little pile over limit, put it together, 0. Okay, so thank you for that. I think that confirms that the resistance is what it claims to be. On this is about 1.8, 2 point whatever, around that kind of range, and this is in the 18, 19 megohm. So some big differences between those two. Now our thermocouples should probably have settled down now. Okay, so see if there's any difference in temperature between the outside world. Get this right, put it on temperature again. So what are we saying there? 23, so fairly consistent temperature. I'm going to touch the outside of the block and see if the actual block is cooler for some reason. So let's just see what that says. I'm going to put it in there. No, I mean, like I say, it's been in here getting to equilibrium with this fairly air-free environment in here. So it doesn't surprise me that that's the same temperature. Let's go into, we've got one of these holes here, these thermal well holes. So let's go right in there. Right, I can see it's right into the end. What, are we seeing any difference? No, this is going to be one of those really dull tests. Let's go and have a look in this one. No, that's really boring, isn't it? Okay, let's go and have a look in the gap between the quartz liner and the reactor. Check. Ooh, hello. Hold on a minute. Hold on a minute. What have we got going on there? No. Don't get too excited. Well, I wouldn't say that's conclusive, and certainly on a Kelvin basis, it's negligible. Potentially, it could be a potential caused by contacting maybe the Cantal, I don't know. Let's pull it out, see what we get. Maybe it's just on that threshold anyway. Oh, now it's stuck at 24. Touch the outside again here. Okay, so the outside saying 23, 20. Okay, it's probably 23.5 in here or on that threshold. So that's the end of that excitement. Let's try the other one. Like I say, if you've got any tests you think I should be doing with the equipment I'm using at a particular time, do say something. No, it's all pretty dull. Okay. So now the next test I wanted to do was to see if there's any voltage that can be captured. And I have the supercapacitor, and the supercapacitor we bought in India. And this is a 5.5 volt, 1 farad supercapacitor. And the reason I purchased this was because I have a feeling that when the active agent breaks up, it really wants thermal heat, and it really wants electrons. And so I proposed a test to Suhas, and Dr. Eagley came on for the ride. And what it was, we did this processing in his foil processor of a rebar. Steel rebar, but I think it was about 10 mil diameter. We have it, I've shared pictures of it. And it did that weird thing where it's under the electrolyte, and it's being hit with the plasma discharges. It's a 180 volt bias, and there was a 2200 volt pulsed discharge. The bias keeps everything moving in the same direction. Anyway, so it's like nothing, it's nothing, and very quickly it goes to like yellow heat. And so we pull it out. The water's below the level of the metal. There's, in theory, nothing contacting it. It's on some nylon supports. And we have a ground lead attached to it, or the return lead for the discharge. And that is cut, and we put a multimeter to it, and lo and behold, we saw an output of 1.3 volts. So the idea was to get this supercapacitor and attach it at that point in a subsequent experiment and see if we could capture some of the power that maybe for some bizarre reason in a piece of freestanding wire, and see what that might be. However, unfortunately, Suhas had to use the ultrasonic transducer to do some cleaning of some particular tubes for a client that was coming, so it was not possible to do that test. So this never really got the outing. Now that test I'm talking about, I do want to fully report that. It was already reported shortly after we got back by Dr. Eagley in Infinite Energy. However, we have tons of videos from loads of different angles and shots of the multimeter and so on. And the interesting thing is that this supports the observation that Lion had, that when in line 2, I think it was line 2, line 1, he turned off the power and then he attached this light bulb to it, and it lit the light bulb for tens of minutes. So, but my speculation is, or my hypothesis is, that the power is not coming from the device necessarily, it might be going to it. So that's all part of what I will talk about in the active agent strange radiation life cycle. You might like to think how that would destroy or overheat transformers, like so many people have experienced. Okay, so that's a little tidbit for you there. Now, what am I doing? What am I doing? Right, so I'm not even sure I want to do this test live, but let's see what we do. Okay, so first I want to see, I guess, if there's anything, any volts coming out of this thing, and discharge it maybe. Actually, I don't think I've got a big fat piece of wire to hand to connect to the radiator, which is kind of let me get my finger over there somewhere. Okay. There's no bolts there, is there? Okay, so there's nothing there. Okay, so let me just confirm that again. I'm putting black to black on the supercapacitor, and I'm putting red to red on here. And we're saying 0.000 volts. So this is discharged. I will touch the two leads together as well, so that we can be sure it is completely discharged. Okay. So how can I get to that grounding metal over there? Whilst I'm looking for a grounding lead, I'm going to take you back here, and you can see the attempt that it's made at reconstruction. On this side, you can see it's made a better job because it had more data to play with, but over this side it had less data, and over this side it had hardly any data at all, so it's messed up. But actually it's not so bad, because this thing here is actually the if I show you back on the robot here, this thing here is the wire connector. So it's done a pretty good job with the time I played with it. I'm going to do a bit of processing here, and what you can do actually is you can colorize this. And not that there's a lot of color in this particular thing, but there we go. So it's looking a little bit more like what we see in front of us. Okay, so a little bit of geometry off there. Now it doesn't like glass so much, so the fused quartz won't come out so well, but yeah, you can see where the thermal wells are. And the actual thing is, this will be very accurate scale-wise. You'll be able to take dimensions off this, and I'll try and put it into standard OBJ maybe, and FBX format, so that you can load it into even free packages, if that is your want. Okay, so that's just a rough one I've done there, and I'll put that full frame for just a few seconds. DC and AC voltage measurements without Supercat should go first. Okay, so are you meaning to do that on the, sorry, Virles QHR, are you meaning to do that on the actual reactors, or on the supercap. If you can think about that whilst I'm off to try and find a piece of wire. Yeah, measure the resistance. My concern is that if there is any power or desire to pull power in this reactor here, that spending too much time grounding that or whatever, it might cause that to go. So I still have not found the wire I want. I'm going to move my camera here before I kill myself. You know, if this was Alan Goldwater's lab, he would have literally spools of wire on the wall, and this, he'll be laughing at me now if he's actually watching. Now, I know this is not perfect, but we're doing what we can, right? So. Say I am here, I'm not going anywhere. I have a piece of wire, hopefully it's long enough. You know what I didn't do? I didn't actually start the backup recording, so I'm getting the backup recording from now. So I seriously hope that they don't do what they did yesterday and strike all this. If anyone can rewind and grab the metrics, that would be really good, just in case. What an idiot. We should have a flight checklist. Actually, normally do. Anyway, I hope everyone had a nice Thanksgiving yesterday, those that celebrate it. Okay. So, a piece of wire here. Okay, and I'm just going to check its resistance. Yeah, it's not a lot of resistance. Okay, getting good contact there. This is. Yeah, okay, so I'm actually using the earth line in this 3-core wire. And I have a radiator over here, and I'm hoping that it's not attached to someone's mains somewhere. That would be just my one. And I'm going to clean off a little bit of area on the radiator so I can make a good contact over there. Hopefully I don't spring a leak by doing this. Depressing. Okay, right. How long our lead is going to be here, but what I'll do is I'll attach it to the so if it's pulling power from the universe, I'm going to attach actually the red lead to the ground. Makes sense to me. Should I get out the soldering iron and solder this on here? Anyway, okay, so this is going to attach to the radiator, which is over there, and that is attached to the red side of our supercapacitor, and the black side we're going to attach to the reactor. Okay. Okay, so I've attached this to the radiator, and I'm going to check it's got no bolts in it at the moment. So can you see? You can see where it's attached to the. Okay, so this wire is going down to that radiator. I'll show you here. It's going down there, up there, and attached to the red side of the super cap. There's probably people out there going, "What is he doing?" Okay, so let's see if this has anything of any note on it. Can you see that? Okay, you should be able to see that. Okay, right, I'm going to attach this one on this side first. Okay, so there's nothing there, and see if anything's happened to our super cap. I've got it on resistance. What an idiot! Right. Let's check it's 0 volts. Yeah, okay, 0 volts. Touch it to here, can you see that? Yeah, and touch it over here. Okay, so there's still 0 volts on our supercap. Okay, so first off, I'm going to attach it to one of the bolts at the end of the reactor. This might be the dullest experiment in the world, but this is science, isn't it? You've got to try these things. So the difference between these reactors and the Lion 2 that I had that did the lighting of the light bulb according to Lion was in those reactors, the copper was wound around and then all the way down in contact to the end bolt. So this may not be a test that does anything when we're attaching it to the end of this. And I don't really want to scrape it off, but let's just put that on there for now and see if anything happens. It's just slightly off shot there. What I've done is I've attached it to the end of this bolt here. And we are going to see if that gives us any joy. So let's see if that makes any difference. Okay, so red over here and onto our absolutely diddly squat. Right, I'll do it to the other one. Of course, it might be so oxidized. This one, it's a little harder to get it to sit on there. I'll just hold it on here for a little while. Okay. This might be tedious, but if you don't do it, you don't know, do you? Nothing there. Right, so the more interesting test potentially is to attach it to the copper. So we'll do the one on this side first. Let's try and get it to do something interesting here. But no guarantees. So this is the one whose heater coil had the 18-19 mega ohm resistance. Okay. Nothing. And we'll do the other side and then we'll do the winding, and that's, I think we'll call that a dud. Now my view is it did all the sparkly business, and it's been over a week now and sitting in various moistures of air. If there would be anything there, it would have died. You'll actually see on our test that we did in India that the voltage did die away. Nothing there, so I'm going to attach last test, and then what we'll do is more time needed. Yeah, okay, all right. Well, I'll tell you what we'll do is we'll do a quick test on the center here, and then what I'll do is I'll attach it to the reactor over here, and we'll just leave it sitting there because I want to show you the microscope looking at the what do you call it, the end of that thermo well, and try and get you to be able to see some of that live. I've not looked at it, so we'll see. I'll capture it on video as well, so I can be able to post that. So if there are people out there that are able to zoom back in this video, I have literally no idea why it wasn't possible, why YouTube killed the video stream yesterday. It's very annoying. One of the things I was saying is I recorded Zeta Lepin and I published it, saying to Parkamov that his calorimeter would, because it's all metal on the outside, is effectively wasting his strange radiation, and so he's lowering his excess by basically radiating it into the room. I'd happen to agree for that, and that's why after I strapped the piece of thermal weld to the front of the webcam over the weekend, I will move to look at the end of the bolt here as a potential area for radiating strange radiation, because John Hutchison established that metals that have this weirdness going on, if they touch other metals, they can infect them. It kind of like diffuses through, and it's not surprising if it is acting a bit like an electron. Okay, so I've held that on there for a little while, and this was on the heater coil, so let's just see if we've got anything coming out of that. And that's a no. So I'm going to put it on to this one because it's easy to wind around, and we'll just leave it there whilst I go to do some microscopy for you. Just leave that on there. Okay. I'm going to do a change of gloves as well, and some little maintenance on the area here, so we don't have so many things lying around. Okay, you have to do this bit quick because I'm going to be kicked out of here in about 10 minutes. So this might be the last quick test of the day, and I'm going to change my gloves to do this. So in fact, I probably will leave that on for a good period of time. Okay. So I'm going to change my gloves. I don't want to contaminate anything unduly. Okay, so I'm going to actually get the camera on here. So this little Narubu lens, it's about $60 in the US, about $70 in the UK, of course. And I'm going to pop this onto basically it sits on here. It's not going to work with those new newfangled Huawei cameras, but basically the light goes through a light guide at the back there, and I think it's even polarized, and then it comes out through a light ring, so you can get right in close, and you can actually rotate this to get the lens to focus. There's a calibration ring, and it does 400 times. So anyway, it sits on there quite nicely like that, and I'm just going to test it. Okay. You see the light ring there? Okay. Now I do have some locators. But they're not stuck onto the lens right now, so I'm just adjusting the position here. Okay. Just checking I've got the calibration tool in here. So it has this little checkered mark. Can you see that? It's going to focus. Use the camera going to focus. There we go. There. And what we do is it's had an upgrade, so it's lost its calibration. So what this does is this fits on the back here into these little slots. There's little three nodules on the back of this, and that fits into there. And it says wobbledy wobbledy hands. Okay. Okay. And then okay, calibration. It's going to let me do calibration here. Focus and ruler. Okay, so you see that? It's actually nicely in focus. And then what it does, it has this thing that you can, ooh, it says a little bit. It's going to sit there. Aye, aye, aye. Now I've moved it out of focus. Sorry guys, I didn't realise it was going to have an upgrade. And it's done an upgrade whilst at some point. Okay, so there we have it. And once the checkerboard pattern is in the correct position, hit the photo to capture button. Right, done. Right, now adjust the bar to match it with the one in the square line. So you have a bar here, and I'm just moving this so that the 2 points are on either side of okay. I'm just going to do this quickly. Okay, it's not the most perfect calibration, but that apparently, if you can see it, is the right distance. I'm going to do that again. So apparently it's been calibrated, but that's not the best I've done. Okay, so we should be able to go back and start doing some imagery with it. Okay. Now we can turn on the micrometers now, and it says that little green bar there. There it's 500 microns, and as I move up and down, it'll let's just change the mode. Okay. Right. It's going to have to be very quick, afraid, because I can hear that my time is basically up. So, fine, I'm going to take out one section of the tip of the thermal well. Which really is in a very bad way. Oh God, that's super brittle. Okay. Yeah, this looks very much like the, oh my, what's happened on the end there? Okay, this looks very much like the steel in Suhas lab. I'm just going to show you that up nice and close, nice and close. Just going to focus in on that. That has been damaged. It looks literally like a piece of carbon. You know what? I'm going to grab a couple of stills on that. Yikes, that's loud. Focus. Sorry about this noise. Yikes. That's when I actually need. I'm going to use my torch here to get. Look at that. That's quite interesting. I'm using the torch on my phone, and there's obviously some issues with the strobing going on, so that's not such a good plan. That's distorted. You see, that doesn't look like a very straight profile. Okay, so I'm going to get right in here and take some video of this, and I'm going to try and keep you in on the loop. Let's see if we can do this. You can watch this happen. How do we do this? Okay, right. Now, ideally, I want something at the other end to prop up the other end of the phone and make it easier for me to locate this. Okay, right. Right. And then, now where you can see that. What are we looking at? It's too high. Okay, can you see what it is yet? Wow. That is looking in a bad way. I'm videoing this so I will be able to upload it later. What have we got there? Seems to be some odd crystals in this little gap here. Okay, I'm going to rotate it around a bit. Yeah, this is in a bad way. So pause that. That'll be the better half saying, "Oh, coming home." I'm back in the room, so I'm going to try and get a measurement on something here. So, and I really will have to go in a minute. So, sorry, but that will be the lot. You'll probably be glad. Per surface, yeah, it's live calling. This doesn't look like any stainless steel, I know. Okay, I'm going to take a photo to get some scales on this. So there you can go, you can see the 500 micron there. Another one of those little crystals. It's a bit sparkly. Let me see if I can get a little bit better light on this. Okay. Oh no. Can you see that? What do we have there? What is that there? I have no idea what I'm looking at, apart from it's meant to be a thermocouple. Let's zoom into this. Oh my god. What on earth is that? Can you see that? Does that look like steel to you? It looks like a beautiful. What the hell are you looking at? Oh my god. It's really beautiful. Now I know why it was sparkly. Look at these crystals. What is that? Look. Semi-micron, Can you see that? They're like little pieces of mirror. Wow. What a beautiful thing. Okay, I'm going to take some quick video of this. I'm going to try and upload this video actually tonight. Zoom right in on this. This is beautiful. Look at that. What am I looking at? I think people need to look into the literature and try and see what it is that we think we're seeing here. Look at that. What on earth is going on? You're seeing this for the first time as I am. And I don't know what I'm looking at. Beautiful, beautiful, discreet. I have no idea. Sorry, can't help. What is that? This is on the fracture line, the first fracture line here. I'm going to try and stop the video, and I'm going to get a photo here to get some scale. Don't look like no stainless steel armor. Where is it? Where is it? Oh, it's there. I'm going to rotate it around a bit. Try and get the other cut line. What is that? Oh my God, there is a clear, what looks like a metallic fiber. What the hell is that? Where's it gone? Oh no, don't tell me I've lost it. I had a higher magnification. Where is it? I don't know where it is. Oh dear. Okay. I'm going to have to go. Otherwise, I'm going to get locked in here the entire night. I'm sorry, there was some sort of fiber. I don't know whether I can actually see it with the naked eye. I'm going to take some scale images down the other end. Okay. Some white deposit in there. I'm going to switch the video. Okay. I don't know what that white deposit is. But it's these down this end, you go a little bit further away from the tip, and it goes away from looking like a piece of carbon to crazy, crazy crystals. Rubber gloves are failing me now. It is like polar ice sheet melting. Yeah. It's actually stronger than I thought. It doesn't seem to have broken much more than it already is. But this is absolutely beautiful what we're looking at here. And in places, it's completely iridescent. Look at that. I don't know if that's capturing it there, where you are. Ooh. Okay, I'm running out of memory here now, so I don't know if you can see that last bit there. It's absolutely stunning. Let's see if I can capture a photo of that area. I don't know if I'm going to capture. Oh, I lost it. I don't know, maybe it's there. There's an area that's really iridescent. Okay, let's see if I can find it. Where are you? Is it there? Okay, that's my lot. Thank you for your time. I'll try and upload some stuff as I can. Put this back in its container. This is going to be strapped probably tomorrow night because I've got no time to do it now, onto the webcam. And we'll use that to see if we're going any strange radiation. Okay. I hope YouTube doesn't delete the stream, but anyway, I've got those beautiful images from the end there to share with you, and the kind of crystallization there is really quite fascinating to me. I don't know about you. Let's seal this back up. Be gentle with it. You want to have a look at the Supercap? I guess we can have one last look to see if it's done anything interesting. I doubt it. I think anything that could have done it would have done it in the moments after the main run of the experiment. But let's see. There he is. It's been sitting. Together. If I get locked in all night, I'll be in the doghouse, as my dad would say. Okay. Volts. No. Volts. And when we get, we touch them together. 0. Good. Right. Oh, you know what? It pulled itself off. Anyway, we'll have a look. I'm not sure it was on there for very long. No, it's dead. Anyway, thank you for your time. On another day. Thank you. Now, I hope this doesn't have a problem. I'm just going to end the stream. I don't know whether I can. There is an option here to make sure it doesn't die. I don't know. I'm going to say goodnight. Thank you, guys. And I'll see you when I'm next able to do something. I'll catch you later. Bye.